Hi, I'm Tim Tyler, and this is a video about the progressive digitalisation of the world. That digital systems are better than analogue ones is a familiar fact to most people today. Digital music media replaced analogue ones. Digital video has largely replaced analogue media. Digital cameras have replaced analogue ones. Digital TV, radio and telephony are making progress as well. Digital signals make an attempt to distinguish signal from noise. Based on the observation that noise often consists of low-level signal fluctuations, digital systems ensure that their main signal consists of large-scale fluctuations and then regularly filter out low-level noise before it grows to a level where it swamps the original signal. This strategy increases fidelity at the expense of bandwidth. In practice, the bandwidth requirements are often actually lower for digital systems because digital compression technology is so much more advanced. Here's Richard Dawkins explaining the advantages of digital systems.
Engineers make an important distinction between digital and analog codes. Phonographs and tape recorders, and until recently most telephones, use analog codes. Compact discs, computers, and most modern telephone systems use digital codes. In an analog telephone system, continuously fluctuating waves of pressure in the air, sounds, are transduced into correspondingly fluctuating waves of voltage in a wire. A phonograph record works in a similar way. The wavy grooves cause a stylus to vibrate, and the movements of the stylus are transduced into corresponding fluctuations in voltage. At the other end of the line, these voltage waves are reconverted by a vibrating membrane in the telephone's earpiece or the phonograph's loudspeaker back into the corresponding air pressure waves so that we can hear them. The code is a simple and direct one. Electrical fluctuations in wire are proportional to pressure fluctuations in air. All possible voltages, within certain limits, may pass down the wire, and the differences between them matter. In a digital telephone, only two possible voltages, or some other discrete number of possible voltages, such as 8 or 256, pass down the wire. The information lies not in the voltages themselves, but in the patterning of the discrete levels. This is called pulse code modulation. The actual voltage at any one time will seldom be exactly equal to any of the 8, say, nominal values, but the receiving apparatus will round it off to the nearest of the designated voltages, so that what emerges at the other end of the line is well nigh perfect, even if the transmission along the line is poor. All you have to do is set the discrete levels far enough apart so that random fluctuations can never be misinterpreted by the receiving instrument as the wrong level. This is the great virtue of digital codes, and it is why audio and video systems, and information technology generally, are increasingly going digital.
As a result of this advantage of digital systems, they have displaced analogue ones in many domains, and are busy displacing them in many more. It is not just processing which digitisation affects. Input-output channels are affected as well. If you look closely at a monitor or at a sheet of laser-printed paper, you will see large numbers of discrete dots. A similar effect can be seen in digital cameras. Digital signals look set to invade many new domains in the future. Today, we are familiar with 2D printers. In the future, we'll have 3D printers. The field exists today, and it's most commonly known as rapid prototyping, and it produces small objects made of a range of different materials. In the future, we will have automated assembly of space frames and reusable building blocks as well. Looking further out, here is Eric Drexler describing some of the possibilities of nanotechnology.
I'll be talking, however, about an information-driven revolution in manufacturing, information-driven in developing the foundational technologies, information-driven in running those technologies, and producing a physical technology that itself is remarkably much more like software, one that essentially can be thought of in many respects as treating atoms like bits.
And here is Ray Kurzweil discussing the potential future reach of information technology.
10 years ago, if I wanted to send you a movie, I sent you a FedEx package. I can now send you an email attachment. Same for a music file or a book. These can now be sent as information files. Those used to be physical products. And increasingly, more and more physical products will become just email attachments. Ultimately, when we have full-scale nanotechnology, which is reorganizing matter and energy at the molecular level, I'll be able to email you a toaster or toast or a blouse or a solar panel or a module to build housing or transportation. And ultimately, what we now consider physical products will become information files, email attachments.
But not everything is better if it is digital. Digital speakers, for example, are currently expensive and of poor quality. However, overall, the trend towards digitalisation is compelling. The human brain uses thresholding ubiquitously, otherwise it wouldn't work at all, but it is not yet entirely digital, which means, among other things, that it can't easily be copied or backed up. This looks like to be a fatal flaw, and brains seem like to be completely replaced by functionally superior digital devices. Also, many humans spend many of their waking hours peering into the digital realm, looking in through rectangular windows at the virtual world of the internet. Once brains go digital, then agents will effectively be living out their lives inside a digital virtual reality simulation. Probably much of their time will be spent in a shared virtual space that does not closely correspond to their immediate physical surroundings. Enjoy.